In our next few videos, we're going to use something called the double angle formulas to evaluate expressions such as sine of 2 times theta and cosine of 2 times theta. So using these formulas here. All these problems are going to basically be similar. The difference is going to be how we begin. All of these problems are going to begin with us drawing a triangle, and what's going to be different is they're going to tell us a different way to find what quadrant to draw our triangle in. So for example, in this case, they're giving us this sort of inequality expression. Our angle, our triangle, is going to be somewhere between pi over 2 and pi. So remembering our unit circle, that tells me that I'm somewhere in quadrant 2. So I'm going to go ahead and draw my right triangle in quadrant 2. And really, they've given me a couple sides of this triangle, and this part should be familiar because we've done things like this before. Because they gave me the sine ratio, that's really just the opposite side of my triangle divided by the hypotenuse down here. So I know the opposite side is 3, I know the hypotenuse is 5. Okay, and then as we've always done, I'm going to go ahead and find that third side, either using Pythagorean theorem, or in a case like this where it's a triple, I know that that missing side is going to be 4. Now what you have to be really careful of is that side that you are finding might be negative. If that side is ever moving to the left or going to the left, or if it's going down, we have to make sure we manually put a negative sign on that side, because it's going in the negative direction. So that's actually going to be a negative 4. Okay, so my triangle's done, and again, before I do this, there's one more thing I want to do. Before I find the sine of 2 theta and the cosine of 2 theta, I want to find just the sine and cosine of regular theta. So as we've always done, we can just base this on our triangle in SOHCAHTOA. So the sine of theta is going to be the opposite over the hypotenuse, 3/5. We already knew that. They told us that at the very beginning. The sine of theta was 3/5. The cosine of theta is going to be your adjacent side over your hypotenuse, so negative 4/5. So with all that in place, I can now answer this question: what's the sine of 2 theta and the cosine of 2 theta? So to find the sine of 2 theta using the formula up above, it tells me to just do 2 times sine times cosine. Oops, sorry for the sloppy writing. So 2 times 3/5 times negative 4/5. And really, all I need to do to multiply these fractions is just multiply along the top. If it helps, put that 2 over 1. Multiply all along the top, so 2 times 3 times negative 4 is negative 24. And along the bottom, 1 times 5 is 25. So the sine of 2 times theta is going to be negative 24/5. And of course, you'd simplify that fraction if you could. That one can't be simplified. Okay? I'll do a similar thing to find the cosine of 2 theta. It's a different formula. It's not, they're not really that similar to each other. So make sure you pick the appropriate formula. But to find the cosine of 2 theta, it's the cosine squared, so negative 4/5 squared. Make sure that's in parentheses. When you multiply a negative number times itself, it's going to always come out positive. And then minus the sine squared, so minus 3/5 squared. Okay? When you square a fraction, simply square the top and square the bottom separately. So negative 4 times negative 4 is 16, positive 16. 5 squared is 25, so my first fraction is 16 over 25. Doing a similar thing over here, I'd have minus 9 over 25 when I square the top and bottom. And then I'll go ahead and subtract those two fractions. I have a common denominator, so I simply have to subtract along the top and get 7 over 25. Simplify it if I can. I can't simplify that one, so 7 over 25 is going to be the cosine of 2 times theta. So that's how that formula works. In the next few videos, we'll take a look at different ways they're going to tell us how to draw the triangle, and we'll add some stuff with square roots to make it a little more complicated. But really, everything's going to be based on these two formulas.